Good evening, all. Am I audible? Can you please someone will respond? Am I audible?
Yes, sir.
Okay, okay. Thank you. So, in this session, we will discuss about regression analysis, and we will see various types of regression. So, before we will start with regression analysis, I will tell you imputation concept in Python. So, for example, you have data set in real time, okay? So, in the data set, there is a possibility that you will get some null values or missing values, right? So, if you are having any kind of missing values or null values, okay? So, how you are going to consider how you are going to replace that missing or null values with some particular value or some specific values, okay? So, because you don't consider null values or missing values, because if you consider these missing values or null values means, so there is a possibility that you won't get proper results, okay? So, what we will do is, so in this session, first we will see about imputation. Uh, After that, we will see more about regression. Let us start with. I hope you can able to see my screen, right? Okay. Okay. So in this session, we will see missing value imputations. If you are having any missing values in your data set, how you are going to proceed further, or how you will execute those things. So, so before that, to use this imputation concept in Python, we need to import some existing libraries. Of course, you are working on numerical data. You can import NumPy as NP. Then, if you are using imputation, okay. So this imputation library will be there in sklearn, okay. So sklearn. So there is a package called impute. From this, we can import. So there are different types of imputers are there. First, we will see simple imputer. So this simple imputer will be there in sklearn dot impute library. Okay. So then we will see from sklearn. So I am importing the basic libraries which are used for the missing values imputation. So sklearn, then experimental, import. So if you want to replace the values in a iterative fashion, okay, so you can use enable iterative imputer, enable iterative imputer will be there. So this is another library. So we are enabling that one. Then from sklearn dot impute import iterative imputer, okay. So you try to import all these packages. We will see. So I am importing four packages. One is NumPy, another one is skimpute, some simple imputer. Then we are trying to enable that iterative importer. Then we are importing this iterative imputer. Okay. So you try to import these things. Okay. Then what we will do is, so first we will see simple imputer. Okay, how this simple imputer will work. Okay, simple imputer. So for example, if you are having some missing value in your data set, so you want to replace that missing value or null value with some strategy. Okay, that strategy is, you assume that there is one attribute or column which is having missing value. You want to replace with mean of those particular values. Okay, so then the strategy you are going to consider for that particular field, you can use mean strategy. Okay, so for that uh, we can use. Okay, so if you want to replace any missing values or null values with the mean values of that particular column or attribute, you can use mean imputer as one of the strategy to replace that missing value, or to replace uh, so this is simple imputer. So you use mean imputer. Okay, we will see one example how this particular mean imputer will work. Okay, so for example, for imputer, you are using some simple imputer. For that, I am creating imputer as one variable. You can take simple imputer. Okay, so whenever you are having any missing values in your data set. Okay, for example, assume that there is one field in your data set which is having nan value. Okay, not a nan value which is having. So you want to replace this nan value with some strategy. That strategy is, you want to replace that value with mean. Okay, so you need to declare your imputer like that. Okay, I want to use simple imputer whenever there is a missing value or any n value. Okay, it will be present in my data set. You use some strategy to replace that value. Okay, so we will see example. So for example, I have some imputer fit function is there. Inside that fit function, so I may have different values. Okay, so this is my fit function. I'm going to have my values like this. So I have 1 comma 2. Then so here I am mentioning. Okay, so I am giving these values manually, but in real time in your data set you will get this missing values or values. In this example, I am giving that nan value by intentionally. Okay, so nan, then I'm giving another value as some 3. So after that, I'm giving some more values. Okay, I'm creating some values like this. Okay, so this is my fit function. So after that, you assume that there is a variable x. Okay, so again, I want to give some values. np dot nan comma 2, then 6 comma np dot nan, then I have some other values, this x variable 7 comma 6. So like this, I have some imputer fit function and some variable x is there. So I am trying to print. Okay, so what do you want to use whenever there is an an variable for this x attribute or x column. Okay, or you assume that this is one variable x variable. Okay, so you want to replace that nan value with some strategy. In this example, we are going to see, we are going to use mean as the one of the strategy to replace that missing value. Okay, let me execute this cell. Okay, you see, see, see what happened is, here your x values you have given as nan comma 2, then 6 comma some nan value, then 7 comma 6. Okay, so initially the np dot nan value is replaced with 4. After that 6 comma 4. Okay, I am just using transform to print this x variable in column format. Okay, so this 6 comma np dot nan value is there. This is going to replace with 3.66 value. Okay, then you are going to see 7 comma 6. Initially you don't have any value here and here, but it is going to replace with some value. That value is whatever the for imputed function you have trained some particular values. Okay, this is your fit function based on these values. Okay, so for example, if you want to replace this value, okay, this is your first value. What it will do, it will take the first three values and it will take that mean value. Okay, so in this fit function we have 1 and nan and 7 is there. So here you don't have any value. For that it is taking 1 plus 7 by, so how many values? These are two values. It will take 1 plus 7 by 2. You will get the mean as 4 here. Is that clear? So that is how it is going to replace, or how you are going to enter if you are having any missing values or nan values in your data set. Okay, so this is how this particular mean strategy will work. Okay, so here also this is 6 comma some nan value is there. Okay, so in this case you can take 2 plus 3 plus 6. You have trained your imputer as with some values. That values are 2 plus 3 plus 6. Okay, you take 2 plus 3 plus 6 by 3. What is that mean? Mean means you need to specify the number of values, total number of values. Okay, so 2 plus 3 plus 6 by the number of values will be 3. You will get the mean as 3.667. Okay, so that's how you are going to replace if you are having any missing values or nan values in your data set. You want to use some imputer function which is available in Python. So for that purpose you want to import the package like simple imputer from sklearn. Okay, this is available in sklearn.impute library. It is available. You can import it and you can use a specific strategy. Then you try to replace those values. Okay, in real time there is a possibility. In this example I have shown only three records or three rows. Okay, some simple values, but in real time you may have lakhs and lakhs of record. Whenever you want to replace that missing values, you can use some strategy, then you can replace it. Okay, so this is example for how to replace the numerical missing values or nan values with the help of mean strategy. Okay, so you are going to have sometimes categorical attributes. Okay, categorical means like labels, names, something like that. Okay, so whenever you want to replace with categorical values, so you need to proceed some strategy. So for mean, for numerical data, the mean kind of the average values will be best fitted for your imputed function. But if you are having any uh, categorical attribute or categorical data, in such cases, what you will do is, so you can use mode strategy instead of mean. You may use mode strategy. So the kind of imputation you are going to call this one as mode imputation. So this is mode imputation. So this will be suited for categorical attributes. So whenever you are having categorical attributes, you can go for uh, mode imputation. Okay. So for this, uh, again, if you want to use, you can use. Okay. So I am creating some data frame with the help of pandas. Based on this data frame, we will see how this simple imputer will work. Okay, so for pandas, you just import pandas as PD, then you create some data frame dot data frame PD dot data frame. Then you give some your data values, like previously you have given some numerical values. Similarly, here also you can specify your categorical attributes. Okay, for example, I have a categorical attribute called A. So then I have another value. Okay, so x. Okay, so like this you may have some different. Just copy. Uh, like this we can give some values. So what I'm trying to do is I'm trying to, okay, so what it will do here, I'm going to give some nan value. I'm giving these values manually, but in real time you will get your actual data. So here I'm giving nan value, then y, then a. Again here I am giving, whenever you are giving nan values, there will be no need of this double quotes. You just specify nan value. Okay, so again nan, then you may have b and y values. Okay, so like this you can create your data frame. So what you will do is here, so this data is like categorical data. You specify what kind of data it is. This is categorical data, so that's why my data type will be category. So then you need to train your impute function. Okay, for that you can take impute some simple imputer. Okay, what kind of strategy you are using means the strategy mode means the most frequency or most what is the definition for mode means the most frequency number of times the particular value will appear means we can consider that one. That strategy we are going to call this one as most frequent strategy. Okay, so that is mode. So we can use most frequent. For simple imputer, the strategy we are using as mode strategy. So that is most, you specify that strategy, strategy. Okay, the strategy is most frequent. Then you print that import dot print function. You print that your data frame. Okay, so I'm just transforming that particular values in column wise. So let me try to execute this particular cell. Let me see. See, see, for example, this is my data frame. I have created one data frame. In the data frame, intentionally, I have given some values like a, x, okay, then some nan value and y, then a and some nan value, then b and y, okay. So what is the strategy we are using is, the strategy is most frequent strategy. So for that, okay, for example, here I have some missing value or nan value is there. So wherever this nan value is there, the strategy is you check A appears two times and B appears one time. So the most frequent means, so A is appearing I mean more times than B. That's why whenever you are having any nan values here, it's going to replace with A. Okay, so AX then AY. Okay, similarly here also I have given np.nan. So now you observe these values X, Y and Y is there. In this case Y appear two times, that is most frequent one. So it is going to replace this value with Y, because Y is most frequent one than the X. Okay, so this is the strategy how you can impute uh, an AND value whenever you are having a categorical attributes. Okay, so is that clear? Any doubts regarding this numerical and numerical imputation and categorical imputation? So if you don't have any doubts, then I will proceed further. Okay, so the next one is mode imputation. The next one is you can use some iterative imputer. Okay, iterative means iteratively you can replace some values. Okay. Then the next one is iterative imputer. For example, whenever you are having multivariant features, okay, this iterative imputer will be more suitable for if you are having a very multivariate features. Okay, we can call this one as multivariate feature imputation. Okay, so we will see one example for how this iterative imputer will work. Okay, so we will see on Python code for this. Uh, okay, so again for this, I think you already imported that NumPy for iterative imputer. You need to import this package NumPy SKLN experimental enable iterative. You need to enable this one whenever you want to do iterative imputers. You need to enable this particular imputer. Then you can import that iterative input. I already imported. Then there is no need. Okay. So if you does not import it, then you can import here. Okay. So I already imported. So I am going uh, directly explaining with the help of one example. We will see how this iterative imputer will work. So you
What was
have
the package? Can you repeat the package name from experiment?
SQL and experimental import enable underscore iterative imputer. So this is the package. Iterative imputer is the package. You want to enable before you
Right.
want to use that one. You want to enable it. Is that clear?
Yes, thank you.
Yeah. If you want, I can share these packages with Google Chat. So you check the chart. Um, I share those packages.
Yeah, thanks so much.
So iterative imputer, uh, then you can specify how many number of time, I mean, iterations will be there. Okay, you specify that iterations with the help of max underscore iteration. I'm specifying some 10 times, then some random state. So it requires some starting state. We will consider that random state as initially 0. So then what you want to do is you need to fit that imputer function. For that, okay, like previous example, imputer fit function. I'm trying to fit this function. Okay, so you take some values like 1 comma 2. Okay, then I'm giving some values manually. Then 1 comma 2, 3 comma 6, then 4 comma 8. Then again in this fit function also you assume that there may be some nan values are there. So like this, we can give some values 7 comma np dot nan. Okay. So this is my imputer function. So after that, you need to test this one, right? So for that, okay, I'm giving something as x test. So here, what we will do is I'm giving some values np dot nan 2 is there. I want to test, okay, whether this particular iterative imputer is working properly or not. Then some 6 comma np dot nan is there. np dot nan comma 6. Okay, so you want to see this. Okay, so here your nan values are there. I want to replace this nan values with some strategy. So in this example, we are using iterative imputer. Then that strategy, okay, based on observation of this imputer function. So if you observe this imputer function, okay, I gave some values 1 comma 2, 3 comma 6, 4 comma 8. Okay. So what does this meaning is? So the second value always it's giving the double. Okay. So 1 into 2 is so 3 into 2. Okay. So the second value will be the double of that particular first value. Okay. 3 comma 6, 4 comma 8 like that. Okay. So I have given some values. Okay. So what it will do is whenever it wants to replace some values, okay, we will try to print this one so that you can understand. Print. So you can use some round off function, then transform to specify that x test. So let me execute this one. You see, see this is test. Okay. Initially you are having an NaN and 2 and 6 comma NaN and NaN comma 6. Okay. What we are trying to do is it is trying to replace that NaN value. Here it is replaced with 1. Based on what strategy means it is using some iterative imputer strategy. In that strategy, if you observe this fit function, so that first value and second value observe it. So always the second value is double it. Okay. For example, here 2. So then what is the value you are going to replace in this particular value means it is going to take replace with 1. Okay. Then only 1 into 2 you will get as 2. Okay. So likewise, so you are having 6 comma n value. So what is the second value it is going to replace it is based on this fit function 6 into 2 that is double. Okay. The second value is double of that particular first value 6 into 2 you will get 12. Okay. So similarly here also you will get 3. Okay. So this is how that particular iterative imputer will work. Okay. So if you want to use iterative imputer in Python whenever you are having a multivariate feature imputation, okay, so you can opt for this one. Okay. So that is brief about this imputation. If you are having any questions, okay. In real time data, there is a possibility that you will get some missing values or non values. So whenever you are having this kind of values, okay, so you want to replace those values with some numerical or some categorical values, okay. So otherwise, what you will get is you will get some errors, okay. You want to replace with some values to replace those values you want to use some strategy. If you are having any numerical data you can go for mean strategy. If you are having categorical data you can use, there are a variety of strategies are there and just I explained only one particular strategy, one idea how you are going to replace. If you want to learn more okay about this thing you may go for more strategies. So for categorical attributes, I used mode as one of the strategy that is most frequent value or most frequent categorical value it is going to replace in that particular NaN value. The next one is iterative imputer. So there may be some fit function based on this fit function it is going to replace those values. Okay. So that is briefly about this imputation. So then we will see any questions regarding the
Yeah,
imputation.
I
Yeah.
have one question. Like the iterative imputer, does it work on categorical data also?
Uh,
Like let's say if I have imp dot fit as a comma z and
yeah, yeah.
b comma y. So like
Hmm.
it's reversing the letters. So will it work on X test?
It will work, but you have to specify that particular strategy. Whatever the this particular fit function you have tried, based on that fit function, it will work. I
So
just
it will
have
work
shown.
on
Hmm,
both categorical as well as
yeah,
numerical data, right?
yeah, but based on this fit function only, it will work.
Okay, okay.
Initially, you need to tell them what kind of technique you are following. You said something reverse like that. You told you need to uh, train your fit function like that. Okay, then it will work. So this
Okay.
is the basic idea about this imputation.
One more question. Like in real world, there will be missing data in number of records. Like there will be thousands and thousands of records. So
Yeah.
if we want to make this fit thing, should do we make it ourselves, or should we let the program run and see if there is any kind of correlation between the data sets, and then figure out the iterative imputer?
So yeah, basically in real-time data set, if you want to replace any missing or NaN values, first you need to go through that particular attribute or column. So you need to understand that particular pattern. Okay. So
Okay, so there's no
okay.
something in Python only which can figure out what is the relation between two columns, say, or we have to do it manually always.
No, no, not manually. You can do like this only. This is like through Python only I done, right? Missing data.
No, no.
In real
Here
time
in
also, yeah.
in fit we are specifying na, that it will always be double. So we are giving it some
Yeah,
relative
first you need to
points.
observe the data. You need to identify that particular pattern. Okay.
Okay,
So what
okay,
kind of pattern involved in the data set?
hmm,
Then you can write some code for your fit function.
okay,
If you don't understand what kind of pattern is there, simply you can't use mean or mode or something,
hmm,
some other strategy to replace that one. First, we need to analyze and we need to identify what kind of pattern is there in that data set.
right.
Then only you can give that fit function or you can write your code for fit function. Then you can use.
Okay, thank you.
Okay. So then we will see about, I think, the week 6. I assume that you have gone through week 6 lecture videos of Professor Ramesh sir. So we will see more about regression. Okay. So basically, so what is regression means? Okay, you want to see or you want to set some relationship among your variables. Okay, so in real time you may have different variables. So we will talk about a brief introduction about regression. Then we will see different types of regression techniques. So can you able to see my screen, right? Just 1 minute. Yeah. Okay. Fine. So basically, we will see in this session, we will see about regression. So I will talk briefly about this regression. Okay. So generally, regression you want to use relationship among variables. So I assume that you have gone through those videos and some basics of this regression. Then I am giving some examples. Different types of regressions are there. Okay, like linear regression, polynomial regression. We will see those things. Okay. So, for example, there is a company. Some company is there. In that company, there are several employees are there. Okay. So we want to try to understand how their salaries depends on their features. Okay, such as, for example, their salaries, such as the features are, you just assume that experience, education, role, city of employment, and so on. Okay, so based on this experience, education, role, city. Okay, so these are different types of features. Okay, based on these features only, a particular employee will get some salary, right? So that is happening in real world. Okay, so for example, suppose you want to predict, okay? So if a new employee is joining with so and so experience and so and so education and so and so role, okay? So what you want to do is you want to predict that particular employee's salary, okay? So whenever you are having a problem statements, okay, a problem statement will be like this, okay? So you are having a set of features, you know those features. Based on that, you want to predict something, okay? Some salary value, okay? That is another variable, okay? So you can able to predict whenever you are having a scenario like this, okay? You need to opt for regression analysis, okay? So most of these statistics and machine learning, okay? So they will use this regression analysis is one of the most important field, okay? Uh, we are having so many regression methods available, okay, in machine learning and statistics, but linear regression is the one of the technique, okay. We will see more about linear regression now. So for that, whatever the features we are going to call them one, again these features we are going to divide into two types, okay. Again, independent features or dependent features, okay. So dependent features, you may call this one as dependent variables or output or responses, okay. So independent features, you may call this one as inputs, regressors or predictors, okay. So these are uh, okay, you need to map, okay, these features, or you may consider as these variables, okay. You need to map these things properly so that you can able to predict, okay. With the help of some features you can able to predict some other features, okay. So if you want to formulate this problem, okay, so we have different types of regression will be there. So why do you need regression means, okay, whether it is linear regression or multiple linear regression or polynomial regression or simple regression, okay, why do you need means, for example, you may have several variables, okay, so with the help of those variables, you want to forecast or you want to predict some future, okay. So in such scenarios, this regression will be helpful, okay. Like I discussed about employee, okay. If you want to predict employee salary based on few features or few variables, so this model will be helps, okay. This regression can be used in many different fields like economics, computer science and social sciences, okay. So every day this regression will be there, okay. Even forecasting, weather prediction, so and any trade market, okay, stock market, okay, they will use some kind of regression techniques behind these fields, okay. So we will formulate this problem. I think you already gone through those videos. I am just giving brief explanation. For example, if you are considering as a linear regression, okay, so you may know linear regression, okay, like it looks like, okay, y equal to generally, you may know y equal to mx plus c, okay. So what is this? This linear regression is, it will look like a linear line, okay. This is the linear line, uh, this is y is one of the variable, okay. So m is the slope, okay, x is another variable, c is the constant, okay. So you are having a linear regression which is having, here you have only one variable, that variable is x, okay. Based on this one variable, you want to predict another variable called y, okay. So here one thing is x, you are going to call this one as independent variables, okay. Why is you are going to call it as dependent variable, because based on this x value only you can able to compute or you can able to calculate y value, okay. So that's why you are calling this x is independent variable and y is dependent variable, okay. So in real time scenarios you may have one variable. If you are having only one variable, okay, you may call this one as a simple linear regression, okay. So if you are having more variables, okay, like x1, x2, x3 and so on, xr, something like that, okay, so you may call this one as multiple linear regression, okay. So you may have different values x1, x2, x3 like that, okay. So in some scenarios, you may have values like this, okay, x and x square and x cube, okay. So there are scenarios you may pass it, the variables, okay. So you will get like this x, x square, x3, okay. So whenever you are having a variables like this, you are going to call this one as polynomial regression. Okay. So these are different types of regressions. So again, okay, so each and every time what we will do is, so you need to see a few things. Okay, whenever you are doing simple linear regression problems, okay, you may assume that I may have some values. Okay, you just consider this is your x and this is your y. Okay, so you may have some values. For example, this is your actual response. Okay, for example, you are having your actual response. This circle representation is your actual response. Okay, you are trying to plot this one as with the help of it. So like this. Okay, this is your actual responses based on your x values. So you may assume that this is x 10, 20, 30. So there will be some values are there. Okay, based on this. Okay, so the y value you will get. Okay, this is your actual response, but you are trying to plot. Okay, something. Okay, some linear line. Okay, that your predicted response will be, this is your predicted response, this is your actual response, the circle is your actual response, the predicted will be, you can consider as square. Okay, so this is your, so what we are trying to do is we are trying to fit, okay, one function, that fit function. Okay, this is one of the fit function. You may have different actual responses. We are trying to fit one common function for your actual responses. Okay, so if you are having actual values of, okay, this is your predicted responses. Okay, so how you are going to predict this thing means, again you are using some function called, okay, so like previously I told y equal to mx plus c, here you can call this one as some function that is f of x equal to, so b naught. Okay, b means some value, constant value, b1 x. Okay, so this is b naught is the constant, again b1 is the slope, x is one kind of uh, independent variable. Okay, so what we are trying to do is, okay, whenever you are having any actual responses, we are trying to plot some model. Okay, that fit line, so we can predict some values based on this fit function. You can predict the forecast or the upcoming values. Okay, so you can call, okay, there will be some line. Okay, you can call this one as, this line as, this is called residuals. Okay, this is residuals, that entire this line you are going to call this one as estimated regression line. This is estimated regression line. So this is your estimated regression line. Okay, so this line you are going to call it as residuals. Okay, so that is brief about. Okay, again this slope. Okay, in technical terms, sometimes we can call this slope as intercept. Okay, sorry, this constant. Okay, here the constant we are going to call this one as intercept. So and b1, okay, b1 we are going to call this one as slope. Okay, we are using some technical terminology, this is slope. Okay, so that is brief about linear regression. If you want to know more about this linear regression, okay, you go through those videos, NPTEL recorded videos. So my intention is I want to show some Python code for this linear regression. Okay, how it will work. I will take some data. Based on the data, I want to demonstrate this simple linear model. Okay, linear regression model. So first we will see simple regression. Then we will see various types of other regression. Okay, so I'm going to my Colab notebook to demonstrate simple regression. I will share my Python notebook. So So what we will do is whenever you want to do some simple, first we will see simple regression. So simple linear regression. So if you want to do simple linear regression with the help of scikit-learn, okay, that sklearn, you need to import some packages, okay. So for that, I'm importing some packages. So if you want to do any linear regression problems using Python, you need to import numpy as one function. Then the next one is from sklearn. So there is a module called linear model. So from this linear model, we can import linear regression. Okay. So already the existing package will be there for linear regression. It is present in sklearn linear model. Okay. So you try to import these packages, import the packages and the respective classes before you want to do any simple linear regression problem. Okay. So then what we will do is I think you already know NumPy will for that numerical values. You may have some array of numerical values. You will use the sklearn dot linear model for regressions, okay, to perform linear and polynomial regression, okay, and make any predictions. If you are having any linear and polynomial regression models, okay, you want to make predictions from them, okay, you can use this function sklearn dot linear model. You can import this linear regression, okay. So then you need to provide some data, right? If you want to predict anything, first it needs some basic data. So you will provide some data. So I am creating some data. This is simple regression, that is y equal to b naught plus b1 x. Okay. So like this, for that I am giving, okay, my x variable as some data I am giving. Okay, I am providing some data. I am giving two inputs. One is x. Okay, I mean one two variables, one is x, another one is y. X is considered as input, or you may call this one as regressor. So I'm giving a array of values for x. Okay, so I have some values. I'm giving 5, 15, 25, 35, like this I'm giving. Okay, 35, then 45, 55. Okay. If yeah, if you want to reshape, you may reshape this data with the help of reshape function. So So this is my x value. Then I am giving some y values. Y equal to np dot np dot array. I am giving some values 5 comma 20 comma 14 32. Let's see. We try to print this x and y. We will see how this print this x. Sorry. First, we need to execute this cell. So I provided some data to work with some example. I have taken this data. Okay. So here x is the regressor, y is the response. Okay, x is the input, y is the output. Okay, it should be array or similar objects. Okay, so I'm trying to print x. Okay, this is my x. Then you try to print y also. You just want to check, okay, how your data will look like. Okay, so this is my y, this is my x values, and this is my y value. Okay, so what we will do is So this is x is having some 1, 2, 3, 4, 5, 6. Okay, this is 6 by 1. The shape of this particular x, okay, our regressive value is 6 by 1, and y is having, if you give okay y dot shape, okay, you will get, if you want to reshape it, you may reshape the y variable also. So this is 6 by 1. Okay, the next step what you want to do is you need to create some model, okay, and you want to fit it. Okay, so for that already you imported some function. Okay, you imported some function that is from sklearn linear model. Okay, so that linear function or linear regression is available in that sklearn linear model library. What you will do is you want to use some model, so for that use that model. So my model is, I'm specifying that simple regression. Okay, simple regression is the my model. You execute this model. Okay, so if you don't have this any errors, it will execute it. So what it will do, you use linear regression is the one of the model. Then what you will do is you try to fit this linear regression with the help of fit function. Okay, so model dot fit, then you specify your regressor and your input and output. Okay, regressor and response, model dot fit. Okay, this is your model. Okay, this is regression model. So then what you will do is so instead of writing okay two lines, okay, like this, you can use only one line also. I will show you how you can write. So instead of writing two different lines, whenever you want to fit, you can write like this also. So the two statements will be assigned to model like this, linear regression dot. Either you can use these two lines or you may go with this syntax. Okay, so anything is fine. So then what you want to do is you want to see, okay, once your model is fitted, you get the results. Okay, you check whether that particular model works satisfactory or not. Okay, you need to check it. Okay, so you can obtain some values. Okay, so in this case I am obtaining that coefficient value r square. Okay, so that root square value, I am trying to get root square value. I am giving the label as root square r underscore sq, then model dot score, specify your x and y. So okay, so with the help of this statement, okay, model dot score, what you will do is you can obtain some coefficient of determination. Okay, that is r square. Okay, so r square, okay, you can call that model, you can get that value. Okay, so then what you will do is you try to print that value, print that root square value. You can use print of, if you want to write any text, you may write any text. Okay, print of coefficient of determination, then you specify that r square, coefficient of determination, specify that r square value. Okay, so let's see, we will try to execute this function, uh, print some typo error. So this is okay, so this is how you can able to compute r square value with the help of linear regression model. Okay, so if you want to compute that slope, that n value, or you want to identify the constant value. Okay, so what you will do is for that you can call, okay, if you want to compute those values, this intercept and in this particular library or in this model, so the attributes of model are, you want to print that slope, okay? So for that, print of intercept, then model dot. So you can call this slope, okay? This is constant, okay? So if you are calling model dot intercept, you will get that particular constant value, okay? Y equal to mx plus we have seen, right? So basically you want compute those slope constant values. So if you are calling this intercept, model dot intercept will be there in this library. You just call that particular value. Let's see. Linear regression object has no intercept. So I think model dot intercept, you can use the terminology as like this. So you need to use like this intercept underscore, okay? So then you can get, okay, this is your constant value in y equal to mx plus c. This is your constant value, some 5.63, okay? So then what you will do is you want to know that slope value, okay? Again, you want to print, okay? So print, what do you want to print? Slope of. So again, you can call model dot. So to print this slope, you can call that coefficient. So this is your coefficient. Okay. So basically, what it will give is this simple linear regression. Okay. So you are trying to compute. You are trying to illustrate how to get that C and M values, or if you are taking y equal to b naught plus b1 x, okay. So you are trying to compute that b naught and b value, okay. So you already know b naught value and b1 value. Then if I will give some variable x, okay. So then you can able to predict y, right? So you know already C value, you know slope value. Then I am giving some x variable, independent variable value. Then you can able to predict the y value. Okay. So this is how you can able to compute a simple uh, a regression problem. Okay. So next what we will do is we will try to you already know these two things, intercept, I mean slope and constant values. So next what we will do is we will try to predict, okay, some value for y, okay. So I already gave some values. Based on those values, these are my x values, right? So these are my x values. Based on this I am predicting my y value. We will see, okay, we will see how this y prediction, okay. For predicting y value I am using the name variable name as y predict, okay. So this is the model, actually this is the model. Once you satisfied with this model, then what you want to do is you want to predict, okay, with the help of either existing or new data, okay. With the help of existing or new data you want to predict some value, okay. So for that what you want to do is you can use predict function, okay. So again this predict function will be available in your model itself. You can call this one with the help of model dot predict, model dot predict. Now what I'm giving, I'm giving my x value here, okay. So let's see. So this executed. If you want to print, you may use some print statement, okay. So print uh, predict response. If you want to print in new line, you may use new line, okay. Then you execute this. Okay, let's see. Okay, this is your predict response based on your x variable, the y prediction. Okay, the y values, it's giving response like this. Okay, so when you apply predict, okay, you are passing that regressor value x value. Okay, so you are trying to print this one. So this is a simple regression model. Okay, you can predict it. Uh, so you will take one example and you try to predict it. Okay. So for example, I will give one example. We try to predict. Okay. So I am giving my. Let's take one example. Okay. So in this example, I have used my x values are like this. Okay. This is my x value. So instead of x that x values, I am giving some new data. Okay. So all of you try this simple exercise. To try some x new. Okay. So I am giving x new some new data. Like 0, 1, 2, 3, 4. Okay. So like this, we have some data 0, 1, 2, 3, 4. What you will do is the exercise with the help of this to try to predict y new. So based on this code to try to do this exercise. Okay. I just modified that data set. Okay. Some simple exercise for simple regression. You take this x data, you predict new value, y value. Okay. So you take some 2-3 minutes time. You try to solve this example. Can you able to do it? So I changed just data only. Previously I have x data like this. This is my x data. Instead of giving this data, okay. So based on these x values, I am trying to predict. Okay, I am trying to forecast, right? With the help of regression model, I am trying to forecast my y values. Okay. So for that, okay, how we can do this thing means, let's see. Okay. So initially you need to tell, okay, what's your data x dot new. So this is my new data. This array np dot. So those are values 0, 1, 2, 3, 4. Then you can use arrange 5 values. Okay, you can use this function directly, or if you want to give, you can give values directly. Okay, so then just check, okay, whether you try to print this x new. So this is my x data 0, 1, 2, 3, 4. Then what you do is you need to use some simple regression model. You predict the y value. Okay, y new equal to model dot predict. For prediction, you require x new. You need to pass your input. So once it is executed, if you want to print, you can print that y new. Okay. So already this model, this is your y values. So
But in this model was used from previous example, no? We
yeah,
didn't.
model is same only. I changed my data.
Okay.
That's it.
Okay. Okay.
Because previously I explained this simple exercise problem. I used the x and y values like this. The same model we are using. Just I changed the data. Okay. So this is simple regression problem. Next, what we'll do is we'll see. So this is simple regression, linear regression problem. Okay. And the next we will see uh, multiple linear regression. Okay. With the help of same sklearn. Okay. Already these packages are there. What is that multiple regression means? Okay. Initially we are going to have x values will be only one value, right? So now you may have for x values. Okay. You may have two values. We will see multiple linear regression. So the same package only for this multiple linear regression also you want to use NumPy, sklearn linear model and linear regression only. I think I already imported those packages. I am directly providing the data. Okay. So my x values whenever you are having multiple linear regression problems, I am giving my x values as like this. Okay. So you may have some values 0, comma 1. You give some values for your x. Okay. So in previous case, you have only one value for x. Now you are having multiple values. So whenever you are giving more, okay, you can implement. If you are having more columns or more values, you give some values. Okay, 15 comma 2, something like this. 25 comma 5. 25 comma 5. 45 comma. I'm giving some values like this. And 55 comma 34. Then 60 comma. Okay. 0 comma 1. I'm giving the x value as 0 comma 1, 5 comma 1, 15 comma 2, 25 comma 5, 35 comma 11, 45 comma 15, 55 comma 34. Okay. So you have x value like this. Then what we will do is initially you are going to have your input and output. Okay. So you may assume that your y values also you are going to have like this. Your y values may be 4, 5, 20, comma 14, comma 32, comma 22, then 38, then 43. So let's see. You can take these x and y values into some array, NP array. Uh, if you want, you can take directly also. I'm just showing different methods. NP dot array x comma. Then you try to print this x and y. You will see this is your x value, array of x values, and this is your y value. So what we will do is like previously you used something, right, for a linear regression. Okay, so use same thing. Okay, same model with the help of this. Okay, single line statement model. Use this same fit function. Okay, you try to use the same linear regression function. Then again same thing. Okay, you compute that root mean square values and intercept values and coefficient values. Okay, so we are trying to take the same existing code instead of typing everything. I am trying to take the same thing. The only difference is initially you have only x value, one numerical value. Now in this multiple linear regression, instead of x value, we are having only one column or one value. You are having more columns. The remaining things are same. Okay, so you try to take the same code. You try to print that r square. Okay. Then print that intercept value. Print this intercept value and coefficient value. So you have see there are two different coefficients. Okay, because you have given two different values, so you are going to get two different coefficient values. Okay? That is this is constant. You are going to have two slopes. That means there are two multiple linear regression. There will be two lines are there. Two regression lines will be there. You are going to have two different lines. Then so you can predict. Okay, you can predict your value from the x value. Use same concept. Okay, so even though multiple linear regression, you use the same concept. Y predict model dot predict x. Okay, use same thing. Then you try to print the predictor response. So this is my with respect to that particular x value. This is your y value. Okay, this is your respective prediction values. Okay, so this is how we can see or you can predict. Okay, the output values whenever you are having multiple columns. Okay, multiple columns of the input. Okay, the appropriate byte. Okay, it will take and it will add that intersection values. Okay, so this is how the multiple linear regression model will work. So most of the thing is same as simple linear regression. The only difference is okay. So whenever you are predicting that output value, it will multiply each column of the input. Okay, it will take that appropriate weight and it will sum that results. Okay, by adding that intercept value. That is the only difference. Remaining thing is same only. Okay, so you just change. Okay, I will give one some sample exercise for this multiple linear regression. You just take some data x new, okay, one exercise problem for multiple linear regression. You just change some data, okay. You take the data x new data as 0, 1. You take 0, 1, okay, 0, 1, comma 2, comma 3.
Just one small question. In simple linear regression, we reshape the X array,
Yeah.
but in this multi one, we didn't reshape it.
That reshaping is nothing but if you want, you can reshape, no issue. Just for visualization, you can use. For example, if you reshape means you will get uh, the column wise values. Okay, if you don't use it for visualization only. Okay, for example, this is reshaped x value. This is a y value which is not done. I mean, there is no reshape.
Right. So answer will be the same in either
Yeah,
case.
the answer will be same only. Reshaping is you want to visualize data, the output in proper manner. For that purpose only we are reshaping it. Otherwise,
Right, right, right.
hmm. You can take some data 0, 1, 2, 3, 4, 5, okay, or 6, 7 like this. Then you use this multiple linear regression. You try to predict some value based on the same model. Okay, you are using linear regression only. The model has linear regression, but you just change the data. You use this data and tell me the new predicted y values.
I have done.
Can you able to predict these y values? Uh,
Yes.
can you please can you please somebody tell me, or you can send your answers in short.
The chat isn't available. Says. I think we are not able to send messages on chat.
Oh, okay, 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 fine. So, what are the y values you are getting?
The first one is the same 5.7776046.
Uh, okay,
Second one is 7.18. Third one
okay,
is
okay.
8.59. and then
Yeah,
9.99, and last one is 11.39.
yeah, right, exactly, correct. So this is how you can do. Okay. So we have seen simple linear regression and multiple linear regression. I'm just repeating, okay. So what is the difference in multiple linear regression is, so X is having a two-dimensional array, okay, which is having two columns, okay. So Y is one-dimensional. Whereas in simple linear regression, this X is having only one column or one variable, okay. Y also having one variable, okay. Only difference is when it comes to multiple linear regression, X is having two or more columns, okay. In so that scenarios, you need to go for multiple linear regression. So the next one we will see polynomial regression. So what is this polynomial regression? The next one is polynomial regression. Implementing this polynomial regression, again you will use same packages, scikit-learn same packages. It is more or less it is same as linear regression only. The extra step, okay, what you are going to add here is, so this is okay. You need to, this is polynomial means it is a kind of non-linear, okay. You may have previously linear things will be there, only one x is there. Now you are going to get non-linear terms such as x square, x cube, x power 4, okay, like this you will get, okay. So those are some non-linear terms, okay. So we will see how this uh, polynomial regression using Python, okay. So uh, we already imported these packages NumPy and linear regression. In addition to solve this polynomial regression, you need one more package that is polynomial features. Okay, so which is available in uh, scikit-learn pre-processing. Okay, so you need to import if you want to solve polynomial regression. You need to import that package that is from sklearn, uh, which is available in pre-processing library, pre-processing, import polynomial features, import polynomial features, import polynomial features, okay. So if you want to solve polynomial regression, you need to import this package, okay. So you try to use this syntax or this package. I'm sharing this package in short. Import that package. Then the next step is, of course, you want to provide some data for your model. Okay, so you provide your input and output data. Uh, like previously, I have some data. Okay, we will take the same data. In linear regression, we have take the data, whatever the data we use, we can take same data. So I'm going to take same data for time being. Okay, while you can take x and now you have your input and output, okay, in a suitable format. Okay, what you want to do is uh, the next one is for whenever you are having polynomial kind of data, okay, you want to transform, okay, initially you are having the x values, okay, in one dimensional data like 5, 15, okay. So this data, what you want to do is you need to convert or you need to transform this data into two-dimensional array. That's why we are using this reshape. Reshape majorly whenever you are using single dimensional or one dimensional data, you want to format it into two-dimensional, you can use reshape, okay. So after that, what you will do is after transformation, so you want to convert this data into um, you are adding some additional features, okay. So for that, I'm giving transformer transformer. I am giving some additional features whenever you want to implement polynomial regression, okay. So earlier you have only x value. Now what I am doing is I am trying to include x square, okay. So for that, what we are doing is we are trying to include some additional features for implementing this polynomial regression, okay. So for this reason, so we are trying to transform that input array, okay, whatever the input data x, okay. So we are adding some additional columns with values of some x square like that, okay. So x square, x cube, x power 4 like that, okay. So like that we can add more number of features. How you are adding these features means, so in polynomial features in this package sklearn preprocessing import polynomial features, with the help of these polynomial features, I am adding that additional, you can use directly, okay, polynomial feature. For example, if you want to have x square value, then you specify the degree, okay. So the degree is 2 means that is the value of x square, okay. Then you can specify that include bias will be false, okay. There will be no bias. You specify this as false. So if you are specifying degree as 2 means that is x square, we are adding additional features for this polynomial. If you are specifying degree as 3 means that is x cube, and specifying uh, another value, okay, that is x power 4 like this, okay. So the degree is an integer, you can add, okay, this thing. Then the bias is always you need to specify either true or false. In this case, okay, it is the bias, okay, the bias or intercept, okay. So that is we are considering as false, okay. Then what we will do is from this you just execute this thing, okay, there will be no errors. You try to fit whatever the data you are having here. So I am using this fit function. So this is polynomial features you are using. That's why you can use this fit function. Okay, polynomial features. Then you try to print that hex values. Uh, so with the help of this x value, what we are doing is in Python we are creating another transformation with the help of your input array. Okay, you can use transform. So you will get some data. Let's see. Okay, what is this x underscore or x new? You give any name. So for example, here I am using, you print this x new or x underscore and observe this difference. So initially you have your x values, okay. 5, 15, 25, 35, 45, 55. Okay, now you see this x, okay, this x new value, this is your x value, this is your x square value. Are you getting my point? Polynomial feature means we have given the degree as 2. Suppose if you give 3, then you see, okay, you execute this one, you try to use fit function to transform your new data, then you execute it. Okay. So, okay, it may be give, okay, maybe degree 3 means it's giving more values, it is unable to print, okay. Let's take only some simple polynomial function, that is degree 2. So 5 is the x value, x square will be 5 square, 15 square, 25 square, 35 square, 45 square, okay. So this is how you can transform whenever you are having a particular one dimensional value, you want to add some additional features, okay. So after that, this is your new x value. After that, you give your model, okay. What your model is? Your model again, it will be linear regression only. You can call that model like previously you called. You create a model and you can fit that model, okay. That model equal to linear regression dot feed dot. Instead of using direct x, you need to feed that polynomial feature, that is x, okay. That new x or x underscore, you use this one, okay. uh, Missing required. So this is model, you can use linear regression. So there will be no errors. Now you try to print like previously root mean square and your intercept and coefficients, okay. So you can use the same functions or same code, root mean square of, you try to print those. Again you can use the new x values, okay. Then you print those values. So the remaining steps will be same as simple linear regression model, okay. The only change is you are using polynomial features library and you are giving the degree as 2 and you are transforming your data, you are adding some additional features, okay. So that is the only difference. The remaining things are same only as mentioned in simple linear regression, okay. You try to print this slope. So then after this, what you will do is you just use this, you call this polynomial feature. Where is this transformer? See, whatever we did, okay. So instead of doing like that, okay, there is a very similar way you can do like this also. Now I am giving, okay. So instead of giving all those different Python codes or different lines of Python code, you can use a single statement or single line of code to do similar task. Quick transform. So it will also give the same thing, okay. So this is how you can able to do okay polynomial regression, okay. So any questions? So this is how you can do polynomial regression. So if you don't have any questions, then the next one we will see advanced linear regression, okay. So the next one is advanced linear regression. So again, for this advanced linear regression, you want to use one more package. If you want to use any advanced linear regression, you want to use one more package, okay. So we will see, we need to import that package. So that is import statmodels.api, okay. So if you want to use any statistical model or any advanced concepts, okay. So you use stat model dot api as you give some alias name as sm sta tats you stats models, not models, stats models dot api as sm. You can import this package if you want to do advanced regression. Then, like previous example, whenever you are having that, you have seen multiple linear regression, right? You take the same data, whatever the data you have used for uh, this multiple linear regression, you take this data, same data for this advanced linear regression. So my x and y will be like this, okay. If you want, you can print, or you may use x, y. You can store this into arrays, okay. X comma y equal to np dot array of x comma np dot array of y. You can take the same data. So if you want to use any advanced linear regression, what you will do is you want to add something for this, right? So I am adding some for my x. I am adding some stat models to compute that intercept b naught. So for that purpose, I'm adding some constant. Sm, my model is I'm adding some constant. So what we are doing here is in advanced these stat models, if you want to calculate that intercept value, okay, so that constant value, it does not take any constant into the account by default, okay. So these advanced models, they won't take by default that constant value. You need to add this constant value with the help of our code, okay, with the help of stat models. For that purpose, we are using the stat models. We are adding that constant value, okay. So that's how we can add that column, okay. So add underscore constant will be present in that library, sm library, stat models library. You use that function to add that constants, okay. So then you can print your x value. So this is your x value after adding that constant, and you can see your y value also. So this is how your x and y, okay, will look like, okay. So this is your x and this is your y. So the constant, we are adding it as 1 here. So if you have seen these x values, so this is my x value 0 comma 1. I added one more constant 1, okay. So for all this 1 is added. Before 0 1 is added, before 5, okay, 5 comma 1 is there, 1 is added, 15 comma 2 1 is added. We are adding one constant. So by default it will take 1 is the one constant. Now what you will do is you try to create a model and you can feed that model, okay. So for that purpose, if you are using any advanced model, uh, instead of linear regression, if you are using any advanced regression, okay, so you can use model dot sm dot ols. So this is the uh, model, linear regression model. It is present in stat models. This is, uh, you can pass your y and x values, okay. So then you can see this results equal to model dot fit. Then you try to print that result summary, print results not summary with the help of this statement. So this is that particular advanced model, okay. This is your entire result summary. So which one is the dependent variable, what is the model you are using. YLS is the one of the advanced stats regression model that is present in this library, okay. So then what is that method they are using, least squares method, date, time, okay. This is your overall summary. So this particular table is having overall summary. If you are having any errors, it will show here, okay. There may be some standard errors which is ignorable, okay. This is how you can able to do different types of regression models, okay. So, so the conclusion from this, okay, regression analysis using Python is you may have seen different models, right? Simple linear regression and multiple linear regression and polynomial regression and some advanced regression, okay. So whenever if you want to predict based on your model, if you want to predict or if you want to forecast any variable, you can prefer this regression analysis, okay. So for that purpose, you are using different kinds of packages available in Python, NumPy, scikit-learn, and the models, okay, linear regression model and any advanced stat models. You can use that respective package to predict or to explore more about this regression, okay. So any questions? So if you don't have any questions, you try to practice this regression models using Python. You can give some x values and you can predict your y value based on your regression model, okay. So if you don't have any questions, I will conclude the session. If you are having any questions,
Yes, thank you for the session.
yeah, okay. Thank you. Okay, thank you. Bye. Good night.
Thank you.